Well, here we are at the class exercises, and we're going to go through and work through these a little at a time. I'm going to pause between questions so I can get them written down, but you're going to have them in front of you, so you don't need to write them down. But because I can't record and have the paper on the screen and the paper to write on all at the same time, I'm just going to pause between. The first one actually says, suppose a function f has an inverse. I didn't feel like writing all that. And it says, if f of 2 equals 3, find each of the following. So this is asking for the inverse of 3. The inverse of 3 means that 3 is the y, and we want to know what the x is. So the x value that corresponds to the 3y value is 2. For these are composition functions, and you always start with the inside. So you're looking for the inverse of 3, which we found. The inverse of 3 is 2. And then they do f of 2. Well, f of 2 is equal to 3. Another way to do it, like a shortcut, is f and f inverse are inverses, obviously, so they cancel each other out. So you should just get what's in the parentheses. We can follow that same thought and do f inverse of f of 2, and we should end up with 2, but let's double check and make sure that that actually works. Working from the inside, we're going to do f of 2, and f of 2 is equal to 3. And then if we do the inverse of f of 3, yep, we're back at 2. So you can take any inverse of the function itself and cancel them out, and you'll get what's in the parentheses. So that's just a quick shortcut. All right, so for number 3, they want us to find a rule for g inverse of x, and they give us our g of x function, and we need to find the inverse function. So the first thing that I want you to see is that I'm only going to do a and b. We don't have to do all 4 of them. They're all linear, and with linear functions, they're easier to work with than any of the other ones that I put on the Nearpod. But the first rule of thumb is to change your g of x to y. And then you're going to switch the variables. Okay, so you change g of x to y first so that you have y and x, and then you switch the order. So for letter A, I'm going to have x equals 4y. And for letter B, I'm going to have x equals 3y minus 2. Now, our job for each of these at this point is to get y by itself. We're solving for y. So to get y by itself in letter A, I just have to divide both sides by 4. So my y is going to equal, this is really like 1/4 x. And that is the inverse of, oops, that's g, excuse me. Inverse of g is 1/4 x. This one, to get y by itself, I have to add 2 to both sides. That gives me x plus 2 equals 3y. Divide everything by 3. And you get y equals x plus 2 all over 3. So my inverse of g of x for this function is, if I wanted to break it apart, 1/3 x plus 2/3. Or you can leave it like that, whichever. You would do part C and part D the same way. You would change your g of x to y, switch your variables, and then solve for y. And when you do that, you'll be all set, ready to go. For number 4, it says name several points on the graph of y equals f inverse of x, and then sketch the graph. And they give us the graph to the right, and the graph of f of x is x to the 3rd. So they tell us all this. I do have the equation, or I'm sorry, I do have the graph here. And one of the things that I want you to do is look at the coordinates. And what we are going to do is we are going to write a table of values for these with the XY table for f of x. So I just wanted to show you that so that we could do that quickly. So our f of x table has 2, 8, 1, 1, -1, -1, and -2, -8. And if we're going to map that to F inverse, oops, that was a little aggressive. There we go. F inverse of x, then all we have to do literally is switch the coordinates. All right, to map your function to your inverse function, you switch y and x. So our new one is going to be 8, 2, 1, 1, -1, -1, and this is going to be -8, -2. So you switch the coordinates to get to the inverse. And now what we have to do is plot this. So here's my graph. Here's my table. And I'm going to do my best to do this right on here. So 8, 2, maybe like, I don't know, here. 1, 1, -1, -1, and -8, -2. So, oh goodness. Like that. Ooh, that's pretty. That's F inverse of x. And we can tell that this is inverse because if you draw your y equals x line, you will see symmetry over the y equals x line. So that's really good. So I'm pretty proud of myself for that. And then part B says find a rule. So to find a rule for this, we're going to do the same thing we did up here in number 3. We're going to take our f of x equals x to the third. We're going to change f of x to y. And then we're going to switch the variables. After we switch, we have to solve for y. So to get y by itself, I have to get rid of the third power. And the only way to inverse a cube is to take a cubed root. So y equals the cubed root of x. So if f inverse of x is equal to the cubed root of x, and this is actually the equation of our cubed root function. So there you go. So for number 5, they ask, is f of x equal to x cubed minus 1, 1-1? And the only way to really test to see if it's 1-1 is to look at a horizontal line test. So what we're going to do is we're going to draw a little sketch. And I mean little because I'm at the bottom of my page here. See where my table is. And the first thing I want to do is look at my parent function, x cubed. So my parent function looks like this. I'm going to draw my parent function in purple. So x cubed is this one. That's my parent. And all we have to do with this, because of that transformation, is slide it 1 unit down. So our real function, the one that they want us to, is going to look like that. Once we get a picture of it, then we're going to do the horizontal line test. Horizontal line test will let us know whether it's 1-1. All we have to do is see if it crosses more than once. If it crosses more than once, then it isn't a 1-1 function. So, just going across. And this passes the horizontal line test. So, yes, it is 1-1. You'll do the same thing with part. Okay, I'm on number 7, and number 7 gives us 3 functions, and they want to know if they're 1-1 and which ones have inverses. So if they're 1-1 and they're functions to begin with, then they'll have inverses. So it's kind of like a yes, yes, or no, no. The first thing is we want to do a horizontal line test to choose whether or not it's 1-to-1. And in this case, this is a no. And the second one, I wasn't very horizontal, but I hope you can tell. This is a yes. So this has an inverse. And let's look at h of x over here. Oh, snap. Look at this. 1, 2, 3. This is a no. No inverse. So remember we talked about on the Nearpod that if it doesn't pass the horizontal line test, it doesn't have an inverse unless you restrict the domain. So because they're not talking about any domain restrictions, then you would just say automatically that f of x does not have an inverse, g of x has an inverse, and h of x does not have an inverse. For number 8, what they're looking for is to figure out which of these functions have inverses. So what we're going to do is take a look at our functions and do them based on parent functions to see if they actually pass the horizontal line test or not. Remember, if they pass the horizontal line test, then they have an inverse. The first one we're going to look at is the absolute value of x graph. The absolute value of x graph starts at 0, 0, and it climbs up y equals x this way, and it climbs up y equals negative x that way. This is the parent function for absolute value of x. If you take a look at this, this does not pass the horizontal line test. So this is no inverse. For this one, x cubed, I think we just did this, starts down, wiggles through 0, and comes up this way. This one, if we look, passes the horizontal line test. So yes, this passes. So yes, it has an inverse. And we found that inverse to be the cubed root of x. For f of x equals x to the 4th, if you plug values in, if you're not sure what this quartic looks like, when you plug values in on both the negative and the positive x side, it's a pretty steep looking parabola. It's not a parabola, but what it does is it climbs real fast and it's real narrow. Okay, so if you notice, this does not pass the horizontal line test. So no, this has no inverse. And then if you take a look at D, look what they did there. This is the domain restriction we were talking about. They restricted the domain. So now they're saying, okay, take this graph of x to the 4th, but only show me where x is less than or equal to 0. So if we want where x is less than or equal to 0, we're only looking at the left side of this graph. Now does it pass the horizontal line test? It sure does. So when we restrict the domain, that really does make a difference. So yes, this will have an inverse, but it will also have a restricted domain and range to match this. Okay, so thank you for going over these today with me. I just wanted to make sure that you understood what a function was, and if it had an inverse, you're going to use the horizontal line test to prove that. We're looking at drawing and finding these values based on switching the coordinates and switching x and y and solving for y again, and looking at some notation up here. All right, so what I'd like you to do is go to your homework assignment, and good luck. If you have questions, let us know.